Okay, Room 50 mathematicians. Today we are continuing right along with Module 3, Lesson 11. And it'll be so easy for you because it's just continuing on what we've already started, right? Last week we talked a lot about using things like the LCD, which stands for? Least common denominator. Yeah, least common denominator. So least meaning smallest, common meaning what? The same, and denominator meaning the bottom number of a fraction, yes? And we found the least common denominator really to add fractions, yes? Today we are doing the same thing. We're going to use the least common denominator to help us find equivalent fractions, but instead of adding, we will be subtracting. To help us remember what it means to subtract fractions, we're going to do some warm-up problems out loud, verbally, okay? What's 1 minus 1/2? 1/2. Okay. What's 6 minus 1/2?
5.5.
5.5. Do you guys agree? Yeah. What's 3 minus 1/2?
2.5.
2.5. So what are you guys noticing about the whole number? It goes from 3 to 2, and then you have 1/2, right? So you always, the whole number goes down by 1, and then and you subtract the fraction. Do you see how you're mentally on a number line? Let's say this is 6. You're subtracting, and this is 5. You're going halfway in between 6 and 5, right? So could you still have 6 wholes at all? No, you only have 5.5, okay? What's 1 minus 1/3?
2/3.
2/3, good. Okay, what's 1 minus 2/3?
1/3.
Good. What's 2 minus 2/3?
1/3.
1 and 1/3. What's 5 minus 1/4?
4 3/4.
4 and 3/4. And what's 5 minus 3/4?
4 1/4.
4 and 1/4. Okay, when we're trying to subtract 1/3 minus 1/5, we could say this in two ways, by the way. We could read this problem as 1/3 minus 1/5, or we could say 1/5 subtracted from 1/3. Okay, so if you're going to use the phrase subtracted from, you have to say the second number first, because you're subtracting it from the first number. It's something tricky, so don't worry too much about it. Okay. Okay. Do we have common denominators in this problem?
No.
Do we? One denominator is 3 and one is 5. Are those common? No. So our steps are going to be the same as when we add. Our first step is we are going to need to find the least common denominator, the LCD. So our first denominator is 3. Let's count by threes. Ready? Go. 3, 6, 9, 12, 15. And we'll stop there because I know for sure that one's going to be common, right? And then my next denominator is 5. So let's count by fives. Ready? Go. 5, 10, 15. Okay, let's stop there because I found the least common denominator. What's the least common denominator? 15. Now my second step is I'm going to make equivalent fractions using the least common denominator. So my first fraction was 1/3. I'm going to multiply that by something over something in order to get a denominator of 15. What do I have to multiply 3 by to get to 15? 5, which means I have to multiply the numerator by 5. Because am I multiplying 1/3 by 5? I'm actually multiplying 1/3 by 5 over 5, which is?
1.
Good. Okay, so that means that 1/3 is equivalent to what fraction? 5/15. Good. And then similarly, 1/5, I can multiply it by something over something to get something over 15, right? What do I have to multiply 5 by to get 15? Ananya? 3, which means I need to multiply the numerator also by 3, which is 1 times 3 is 3. That means 1/5 is equivalent to 3/15. Okay? Then step 3, I need to rewrite the problem and solve it. This time instead of writing 1/3, what should I write? 5/15. Okay? And then I'm minus, because I'm rewriting the problem. And then instead of 1/5, what should I write? 3/15. Okay. Now if I'm starting with 5/15 and I'm going to take away 3 of those 15ths, how many 15ths do I have left, everyone? 2 15ths. So the answer to this problem is 2 15ths. How is this problem 1 3/4 minus 3/5 different than the first two problems we did? Well, do you guys notice how the first term, a term is like each number in your problem, is a mixed number? Do you guys see that? So when your first term is a mixed number, it changes things a little bit, okay? Overall, the general concept is the same, but we have another piece to think about, which is the whole number piece. So there's 3 different methods that I'm going to teach you how to approach this problem, okay? You need to be able to do all 3. but you can also eventually choose the one that you're most comfortable with. Okay, the first method is to turn the whole number into a fraction based on the second denominator. I'll show you what I mean by that. Okay, so do you guys agree that 1 3/4 is the same thing as 1 plus 3/4? Right? Okay, and don't forget our problem is 1 3/4 minus 3/5. Now, what are some different versions of 1 I could say? Could there be 1 over 1? Is that 1?
Yeah.
2 over 2? 3 over 3? 4 over 4?
Yeah.
5 over 5?
Yeah.
102 over 102?
Yeah.
Okay, so my method number 1 says I'm going to turn the whole number into a fraction based on the second denominator. What's my second denominator? 5. So instead of calling it 1, what if I call it 5/5? Is that still 1?
Yeah.
Did I change the value at all? No? Okay. So 5/5 plus 3/4. Do you guys agree that's 1 3/4? Right? Okay. And then I have, don't forget, I still have this part, minus 3/5. Yes? Now, let's look. Do you guys see how I have this, 5/5 minus 3/5? Right? Can we do that in our head? What's 5/5 minus 3/5? 2/5. So now what I have is 2/5, after I take care of that part, plus 3/4. Now can we do this problem? Yeah. Well, we still need to find an LCD, right? What would our LCD be? 20, okay. So then we can rewrite the equivalent fractions. 2/5 is going to be 4 times 4 over 4 to get 8/20ths, yes? And then 3/4 is going to be how many 20ths? 5 over 5 equals 15/20ths. So now we can do our 2/5 plus 3/4. Go ahead and make sure you take good notes and finish this problem in your notebook. So when we do 8/20ths plus 15/20ths, we get 23/20ths, which is 1 3/20ths. So that's our answer. Method 2 says keep the whole number separate. Okay, well, once again, my problem is 1 3/4 minus 3/5. Okay, well, I still know that 1 3/4 is 1 plus 3/4, and then I have minus 3/5. Do you agree? If I'm going to keep that separate, I'm going to find the least common denominator for my fractions right now. So what's my LCD?
20.
Okay. Okay, let's write our equivalent fractions. 3/4 is going to be equal to how many 20ths? Well, how do I get from 4 to 20? What do I need to do? Multiply by? So I need to multiply 3/4 by 5/5. So that's 15/20ths. And then 3/5 is going to be how many 20ths? Well, I need to multiply by 4/4. Yes? Okay, so that's 12. So now, let's rewrite this entire problem with our equivalent fractions. We have 1 plus 15/20ths minus 12/20ths. Okay, what's 15/20ths minus 12/20ths?
3/20.
3/20. So this is, do you guys agree this is 1 plus 3/20ths? Otherwise known as 1 3/20ths? So you can see we got the same answer as we did using method 1. Method 3 says I could also change that mixed number into an improper fraction first. Okay, well, what that means is, again, just like before, I know that 1 3/4 is the same as 1 plus 3/4, yes? Right? Now, 1 is the same as 4/4, isn't it? Plus 3/4. So is 1 3/4 the same thing as 7/4? Do you agree? Yeah? Yes? Is 7/4 the improper fraction form of 1 3/4? Yeah. And in order to make it improper fraction, you just first separate out the whole number and the fraction, and then rewrite the whole number as a fraction with the same denominator. Okay? You might know a different method to do it. That's not the correct way to do it. I want you to show it this way. Now we can rewrite this problem. Instead of 1 3/4, let's write it as an improper fraction. What's the improper fraction form? 7/4. And we're still taking away 3/5. Okay, our LCD is still what? 20, because our denominators haven't changed at all, right? So, our LCD is still 20. Let's write some equivalent fractions. 7/4 is going to equal how many 20ths? Well, how do I get from 4 to 20? I multiply by 5, so I need to multiply 7/4 by 5/5 to get 35/20. Yes? And 3/5, we did it earlier, but we'll just do it again. 3/5, we need to multiply it by 4/4 to get 12/20. Okay, now, let me give ourselves a little more room here. If I have, now I can rewrite the problem. Instead of 7/4, I can write 35/20. And instead of minus 3/5, I can write minus 12/20. If I have 35/20 and I take away 12 of them, how many do I have left?
23.
How many? 23/20. Is that the same as 1 and 3/20?
Yeah.
So once again, we get the same answer.